बिस्मिल्लाहिर्रहमानिर्रहीम नहमदुहु व नुसल्ली अला Muhammad Rasulullahi Kareem. This problem is related to chapter multiple integral of integral calculus. Show that double integration x plus by dA region R is equal to 250 upon 3, where R is the region in the first quadrant inside the circle x square plus y square is equal to 25. I denote this integral with I. Therefore, let I is equal to double integration R x plus y dA. We have to prove this value is equal to this. Here R is a circle in first quadrant. First we should draw this circle. Here x square plus y square is equal to 25. We can write it as x minus 0 whole of square, y minus 0 whole of square is equal to 5 square. This equation denote that center of circle is origin 0 0 and radius of circle is 5. We can draw it in xy plane. When we plot it in xy plane, this is center of circle 0 comma 0 and radius is 5, so that this value also 5 and coordinate of this point is 5 comma 0 and coordinate of this point is minus 5 comma 0 and this is y axis, this is x axis, and coordinate of this point B you can write, but in this problem we will not use this point, and coordinate of this point B dash is equal to 0 comma minus 5 and coordinate of this point A dash is minus 5 comma 0. We have to integrate in this region. This is region in first quadrant. It is denoted by R. We will cover this region with a strip parallel to y-axis. So we must integrate with respect to y first and then integrate with respect to x later. The value of integral I becomes according to limit. Region is covered by strip parallel to y-axis. All strips start with x-axis where y is equal to 0. So limit of y start with y is equal to 0, and ends of all strip on this circle where value of y we can find with the equation of circle. If we find y square, we get 25 minus x square, and if we find y, then we should apply square root on the right hand side. Square root have two value, plus and minus. For first quadrant it is plus square root 25 minus x square. This value y is for all the strip. So upper limit is square root 25 minus x square. But here we are saying that all strips lie in between these two lines between y-axis and this line. This line is away from origin is unit 5 and this is ordinate parallel to y-axis. Therefore equation is x equal to 5 and equation of y-axis is x is equal to 0. So all the region lie between these two lines, x is equal to 0 and x equal to 5. We have to integrate only this value x plus y, and dA equal to dy into dx. dA denote elementary area, dA First we should integrate with respect to y, because this is limit of y. There are other math fashion of writing this, in which dx we write dx dy also. But if we write limit of y here, which is variable, so integrate with respect to y first, because y limit is variable but x limit is constant. So we will write integrate this term by term. There are two terms. When we go to integrate this value of x from 0 to square root 25 minus x square, we can write x as x into 1, and we have to integrate with respect to y, and then we go to integrate this value y with y is equal to 0 to square root 25 minus x square with respect to y, and close this bracket, and this value will integrate with respect to x from 0 to 5. 0 to 5, this is limit of x from integration. X can be take out from sign of integration, only leave here behind here 1. Integration of 1 with respect to y is y, and apply the limit y is equal to 0 to 25 minus x square. Integration of y to the power 1 with respect to y is power will be added by 1 and becomes 2, and also divide with 2 according to formula. And limit of this is also y is equal to 0 to square root 25 minus x square. This value, after solving this, we integrate with respect to x from 0 to 5. Write x equal to integration x equal to 0 to 5. We have to work in this value. Write upper limit value of y, it's 25 minus x square minus lower limit value of y is 0. Upper limit minus lower limit value of y this, value by this, plus and also we can take out 1 by 2 outside this bracket and apply upper limit, put the value of y this value in here, 25 minus x square whole of square, because here y is square, minus lower limit is 0, so 0 square. Then we integrate with respect to x after solving this. There are two terms. Integrate this value, apply linear property of integration and integrate these two terms. There are only two terms because these values are 0. So integrate with respect to x square root 25 minus x square with respect to x will go here and here, and this integration sign will go here. 1 by 2 is constant, take out 1 by 2 outside the integration sign. X equal to 0 to 5, and we know that square root on squaring they will cancel each other, only we get 25 minus x square, and we have to integrate with respect to x first. Now we can write this value as I write this value first and x after it, write it after this value. This is value of I and required integral. I write limit 0 to 5 and integration 25 minus x square root 25 minus x square x dx. Second term is plus 1 by 2 integration from 0 to 5. We can integrate these two terms term by term. So I apply here square bracket and take this integration sign to 25 and we can write 25 as 25 into 1 with respect to x minus integration of x square from 0 to 5 with respect to x. Close bracket. This bracket is starting bracket is this, and close bracket is this. Open bracket is this, and close this is a square bracket. If we for this integration let 25 minus x square is equal to t square, then on differentiating we get 0, differentiation of 25, and in differentiation of x square is 2x dx. Also differentiation of t square is equal to 2 into t into dt. Cancel out t, and transposing the minus sign on the right hand side we get t dt. And limit also will change. Limit when I put x is equal to 0, we get t square is equal to 25 minus 0 square. Therefore we get t is equal to 5 when x is equal to 0, t is equal to 25. This is a lower limit. For upper limit, where x equal to 5, lower limit will be find. Upper limit will find with this relation t square is equal to 25 minus x square, but x value of x is equal to 25, x value of x equal to 5, which becomes on squaring 25, and we get t square is equal to 0, so t is equal to 0, which is upper limit. This is lower limit, this is upper limit. We put this substitution, then limit will change according to this. Lower limit becomes 5 and upper limit 0, and I write square root, and this value t square as we let here, and x dx is becomes minus t dt. After this we write 1 by 2 and apply square root, and take 25 out from this bracket, and we have to only integrate 1 with respect to x. This integration of x square, we know that it increase by 1 power, x square become x cube and divided by 3, and apply limit 0 to 5, and close this bracket here, and take out minus from this sign of integration. Then this value becomes t is equal to 5 to 0, and you can take out t square from square root, which become t, and this t also dt. Minus sign I take outside the square root, plus 1 by 2, 25 integration of 1 with respect to x is x, limit is 0 to 5, minus you can apply upper limit and lower limit. Put value of x is equal to 5 for upper limit, and minus lower limit for x is equal to 0. I apply upper limit minus lower limit. It become t square, and you can also change the sign, change the limit, upper limit, interchange the limit, upper limit and lower limit with this sign will becomes positive after changing the interchanging the limit, and this becomes t square dt. Plus 1 by 2, 25. You can calculate easily. I upper limit apply here, upper limit 5 and minus lower limit, and put the value of x here. Minus this value becomes 0, because 0 cube is 0, so put only 0 here on, and 5 cube is equal to 125 upon 3 minus 0. You have to not need to write 0 here. The integration of t square is t cube upon 3, and apply limit 0 to 5, plus 1 by 2, and this multiplication becomes 125 minus 125 upon 3. You can take LCM and make this value as fraction, so that you can subtract this value from this. Apply here upper limit minus lower limit. And in this you can take LCM, which is 1 and 3 is 3, multiply 3 here, 3 into 125, or multiply 1 here, 1 into 125. You can calculate according to your wish. 5 cube is 125 upon 3 minus 0 cube is 0, plus here we are seeing that 125 is 3 times minus 1 times 125 1 times, so we get 2 times 125 all upon 3. You can also cancel out 2 with 2 numerator and denominator, and this term becomes 125 upon 3, and also this value becomes 125 upon 3. These are two like fractions. You can add numerator directly and write denominator only 1 times, therefore this becomes 250. Therefore value of I is double integration with region, R is region of circle in first quadrant, and x plus y dA is equal to, we have to prove this value, so we proved this quadrant demonstrandum. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.